Welcome back, students. Today we will be dealing with Archimedes Principle, its application and about relative density. Okay. So as I told earlier, today we will be dealing with Archimedes Principle. So have you heard about a Greek scientist Archimedes? So let's start this session with a story then. Okay. This Archimedes ran through the streets yelling Eureka, Eureka. Let us know the reason why. And this Eureka means I got it, I got it. Let us see why he ran through the street yelling Eureka. Okay, let us begin this session with a story. And the story goes like this. That is, in ancient time, and the Roman emperor, for a Roman emperor, a crown was made of gold. And that Roman emperor called this Archimedes and asked him to determine whether the crown is made of pure gold or not. Okay. Archimedes was a bit confused because this crown is having an irregular shape. So, to determine whether the crown is made up of pure gold or not, he has to determine its density. In order to determine the density, we know density is determined using the formula density is equal to mass by volume. So, if we can find the density of the crown and if the density of the crown is equal to density of gold, he can clearly say that the crown is made up of pure gold. But in order to find the density of crown, he need the mass of crown and the volume of crown. Mass of crown can be weighed very easily using a weighing machine. But in order to find the volume of an irregular shaped crown is difficult. So he thought about it. Okay. So once what he did was, once he was taking, one fine day was taking bath. And finally when he got into the bathtub, what he observed was, when he got into the bathtub, the volume of water rose. The volume of the water rise up when he got into the water. Suddenly he got the idea to find the volume of the irregular shaped crown. That is, a submerged crown will displace an amount of water that is equal to its own volume. That is, when you immerse this crown into water, when this crown gets submerged, it will displace an amount of water out. And the amount of water displaced will be equal to the volume of the object. And based on this, he formulated the Archimedes Principle. And the principle states that when a body is immersed partially or completely in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. It experiences an upward force which is equal to the weight of the fluid displaced by it. So, Archimedes Principle is, when a substance is immersed partially or completely in a liquid, the upward force experienced by the object will be equal to the weight of the fluid displaced. So, when we immerse an object into a fluid, amount of fluid will be displaced and the weight of the displaced fluid will be equal to the upward force, and this is Archimedes Principle. Okay. So, coming back to story, once Archimedes has determined the volume, he found the density of crown using the equation mass of crown in air. To find the mass of crown in air, he can use a weighing machine divided by volume. To find the volume, what he did was, he just submerged the crown into a beaker full of water. and the amount of water is displaced will give you the volume of the object. Thus, he calculated the volume of the crown and hence he calculated the density of crown. And if density of crown is equal to density of water, then he can conclude that the crown is made up of pure gold. That is how he come into the conclusion of Archimedes principle. Now, before passing on to the application of Archimedes principle, let us get acquainted with certain terms. Okay, the first term is relative density. It is relative density. Relative density means it is a ratio of density of a substance to density of water. Relative density is the ratio of density of substance to density of water. Density of substance to density of water. That is, we are just comparing the density of a substance with respect to water. Or relative density means how heavy or light a substance is when compared to water. Okay, and this is the formula to find relative density, that is RD is equal to density of substance by density of water. For example, if you are given relative density of silver is 10.5, if you have given a statement like this, what is the meaning of this statement? This statement means relative density of silver can be written as density of silver by density of water, and according to the statement, relative density of silver is 10.5, which is equal to density of silver by density of water. That is, density of silver is equal to 10.5 into, take this density of water to the other side, so it becomes into density of water, which means relative density of silver is 10.5 means silver is 10.5 times as heavy as water. Silver is 10.5 times as heavy as water. And this relative density, since it is a ratio of densities, this relative density has no unit. It has no unit. Since it is a ratio of two same quantities, that is densities, it has no unit. Okay. Now, let us do a problem related to relative density now. The question is, for question you can refer your textbook, page 142, example 10.7. Question is, relative density of silver is 10.8. The density of water is 10 raised to 3 kilogram per meter cube. What is the density of silver in SI unit? So, relative density of silver is given as 10.8 and density of water is given as 10 raised to 3 kilogram per meter cube. We need to find the density of silver. Now, we have the formula relative density is equal to density of silver by density of water. Therefore, from this, density of silver can be calculated using the equation relative density into density of water. Take this density of water to the other side. It was division here. When it moved to the other side of the equation, it becomes into. Now, substitute the values given. Relative density of silver. Relative density of silver is given as 10.8 in the question. Into density of water is 10 raised to 3. So, density of silver is 10.8 into 10 raised to 3 kilogram per meter cube. 10.8 into 10 raised to 3 kilogram per meter cube. This is how you solve the problems related to relative density. Okay. Now, before passing on to the application part, as we have already discussed, the formula to find density is mass by volume. Okay, you have to keep this formula in mind. Then the next thing that you should keep in mind is, suppose if an object is immersed in a liquid, as Archimedes told, when an object is immersed in a liquid, this object has a weight. This object has a weight, and that weight always acts downwards. The weight of the object always acts in downward direction. The weight of the object always acts in downward direction, and weight of the object will be equal to gravitational force. As we have learned in the previous session, weight of the substance is always equal to the gravitational force, and it always acts in upward direction. And according to Archimedes principle, the fluid in which the object is immersed, this fluid will give an upward force onto this object. This fluid will give an upward force onto this object. That is, when an object is immersed into a liquid, the object experiences two forces. One, a gravitational force which is equal to its weight acting in downward direction, and the other one is an upward force which is given by the liquid, which is given by the fluid in which the object is immersed. So, the two forces are the gravitational force acting in downward direction, which is equal to weight. The second force is an upward force given by the fluid. Now, if density of substance is greater, density of this object is greater than the density of the fluid in which it is immersed, the object will sink. The object will sink. If density of substance is less than the density of the fluid in which it is immersed, it will float. For time being, just remember these 2 points. In detail, we will learn in next session. Okay, for time being, just remember that if density of the object is greater than the density of the fluid in which it is immersed, it will sink into the fluid. If density of the object is less than compared to the density of the fluid in which it is immersed, it will float. In detail, we will be dealing in the next session. So, just remember these 2 points. Okay. So, if an object is immersed in a fluid, it will experience two forces, a downward force called gravitational force which is equal to its weight, an upward force given by the fluid. And if density of object is greater than the density of fluid, the object will sink, and if density of substance is lesser than the density of fluid, the substance will float in the fluid. Okay. Now, let us see certain application of Archimedes principle. First application is submarine. A submarine has a tank. A submarine has a tank, and when submarine dive into the sea, what happens is the valves of this tank will gets opened up. The valves of this tank gets opened up. The valves of the tank gets opened up, and through the valves the water will enter. Through the valves the water will enter and the tank gets full. So, the total weight of the submarine will increase. The total weight of the submarine will increase. So here, when the submarine dives into the sea, the valve gets opened up and the tank gets filled with water. When water is filled in the tank, the total weight of the submarine got increased. So during diving, as the water enters into the tank, the total weight of submarine got increased. And we know that, as we have said earlier, when an object is immersed in a liquid, it experiences two forces, an upward force and a downward force, which is equivalent to its weight. So as weight increases, we know that weight always acts in downward direction. So as weight increases, weight is also equal to the gravitational force. So as weight increases, the downward pull increases. As weight of the submarine increases, since weight is acting in the downward direction, the submarine experiences a greater downward pull, which helps in the submarine to dive into the deep sea. Now, when submarine rises to the surface of the sea, what happens is the tank is pumped with compressed air, so that when this air is pumped in, the water will be forced out of the tank through the valves. The valves will be opened and the water will be forced out of the tank. So here, weight of the submarine will get decreased. Weight of the submarine will get decreased. So the downward pull gets decreased. Weight decreasing means the downward force gets decreased. So the submarine rises up. Okay. This is how a submarine dives and rises up. So when a submarine dives, what happens is the valves get opened up, the tank gets filled with water, which increases its weight. We know that weight always acts in downward direction. So a downward pull has got increased, which helps the submarine to dive. And when it rises up to the sea, what happens is the water will be forced out of the tank through the valves with the help of compressed air. So the weight of the submarine gets decreased. So weight got decreased. That means the downward pull got decreased and the submarine will rise up. Okay. Now moving on to the second application, that is hydrometer. Hydrometer is a device which is used to determine the relative density of fluids. Okay, and this hydrometer consists of a long cylindrical glass tube. It consists of a long cylindrical glass tube, and this part of the hydrometer is known as stem. And at the bottom part it has a bulb, and in the bulb it is filled with lead shots. Bulb is filled with lead shots, and on the stem we have a scale. And when we immerse, and this lead shots which is there in the bulb helps the hydrometer to float vertically in fluid. This lead shots enables the hydrometer to float vertically in the fluid. And when we immerse this hydrometer into a liquid, the hydrometer reading will give you the density. Depending upon the density of the liquid, the hydrometer float or sink. Depending upon the density of the fluid into which the hydrometer is immersed, the hydrometer will float or sink. As we have already mentioned earlier that if density of substance is greater than density of fluid, the substance will sink, and if density of substance is less than density of fluid, the substance will float. So, this our hydrometer will be immersed into the liquid. Depending upon the density of fluid, the hydrometer either sink or float, and it will give a reading. It will show us a reading too. As it sink or float, it will give us a reading too, which corresponds to the relative density of fluids. Next example is of, we also have a device called lactometer. Lactometer also works based on the principle of Archimedes Principle. That is, it is a device which is used to measure the purity of milk. Same way as we did for hydrometer, it also has a cylindrical glass tube with a stem and a bulb. It will be inserted into the milk to check for the density. The density of the milk will be compared with the density of pure milk to check the purity. The device name is lactometer. Okay. Now, an additional information is, in ships, in loading ships, that is in cargoes, we have a line called plimsoll line. And this plimsoll line marks the level at which a ship or a boat float in water at different locations. That is, at different locations, sea water will be having different densities. As temperature or salinity of the sea water varies, density of the sea water also varies. As density varies, we know that the object will either sink or float. So, to get an accurate level at which a ship or boat float, we have a safety line called plimsoll line in ship, and it determines the level at which a ship or boat floats depending upon the density of water. And this line indicates how much load is allowed at different types of water. So, seeing the plimsoll line, one can load the cargo so that the cargo can reach safely without sinking. Okay. So, that is the line called, the safety line called plimsoll line. Hope the session is clear. We are winding up the session. This is all about Archimedes Principle. Archimedes Principle is when a liquid is immersed, when an object is immersed into a liquid, it will experience an upward force which is equal to the weight of the water displaced. And the points to be remembered is, if density of substance is less than the density of fluid, it will float, and if density of substance is greater than the density of fluid taken, it will sink. And applications of Archimedes principles are hydrometer, submarines, lactometers, etc. And we also learnt about a term called relative density, that is density of a substance to density of water is known as relative density. Hope this much is clear. We are winding up. Thank you.